Hello, in this video we'll learn how to do the nth derivative of sine ax plus b. So if we have been given the function y is equal to sine ax plus b, we'll try to figure out the nth derivative for this. So first we'll find the first derivative. So first derivative is y prime, or it also can be written as dy over dx. So we know that if we have the function given as sine x, then its derivative is equal to cos of x, right? So which means in the same way, if I have to do the derivative of this, it's going to be cos of ax plus b. But now we have to use the chain rule and multiply this by the derivative of ax plus b, which is just a. Now, to get the nth derivative, there needs to be a pattern. If we are having the function given us to as sine, the first derivative is cos, the second derivative is again going to be sine, so we wouldn't be able to write it as a generalized formula. So what we need to do is we'll see if we can express this cos in terms of sine. So what I'm going to do is I'm going to draw the sine and the cos functions over here. So this is our sine function. So this is 0, this is 2 pi, and this is our pi. Now on the same graph, I'm going to draw the cos function. So the cos function will go something like this. So if you see, this is over here pi over 2, and this over here is 3 pi over 2. If sine x is translated pi over 2 onto the left, we get the cos function. So which means I can write it down as sine pi over 2 plus x gives us cos x. So here we have cos x. So I should be able to write it as sine pi over 2 plus x for me is ax plus b, and then this being multiplied by a. Now to do the second derivative, we again have sine of theta, where theta is pi over 2 plus ax plus b. So the derivative is going to be cos pi over 2 plus ax plus b. But now this is going to be multiplied by the derivative of this function inside the bracket, which is the angle. So the derivative of this is just going to be a. If I multiply a with the a, I get a square. Again, we will try to change it into the sine function. So this will be sine pi over 2 will be added to this angle written inside. So pi over 2 plus pi over 2 gives 2 pi over 2 plus ax plus b and multiplied by a square. Now we'll do the third derivative and then derive the nth derivative. So for the third derivative, it can be written as the derivative of sine is again cos. So 2 times pi over 2 plus ax plus b, and that being multiplied by the derivative of this is again going to give me a. So a times this a square gives me a cube. And then again, if I want to write it in terms of sine, I'll add pi over 2 to it. So we can write it as sine 2 pi over 2 plus pi over 2 gives us 3 pi over 2 and plus ax plus b. A cube we already have it, so raised to the power 3. Now, if we try to get the nth derivative of this, we can see that for the first derivative, a is to the power of 1. For the second derivative, a is to the power of 2. For the third derivative, a is to the power of 3. So for nth derivative, a is going to be raised to the power of n. Another thing is that in all the cases, here we have the function was also sine, and each of the derivatives we have represented it in terms of sine. So we are going to write sine. First derivative was pi over 2 multiplied by 1. Second derivative was pi over 2 multiplied by 2. Third derivative is pi over 2 multiplied by 3. So nth derivative is going to be pi over 2 multiplied by n, and plus ax plus b written as such. So this is our nth derivative for the function y is equal to sine ax plus b. I hope you understood the concept. See you in the next video. Bye-bye.